Good evening, everybody. I'm going to go through a few nice overclocking profiles that work really well for the RTX 5090. And there's quite a few, really. It'll vary a little bit based on your silicon. And of course, how your card is set up. We've got our card water cooled and it is shunt modded, so we're not going to be limited by power or anything like that. The main limitation that I'm experiencing is not even voltage, but temperatures. I'm still going to be seeing temperature limit. Of course, these cards are going to run maximum frequency when they're at 30 Celsius or less, okay? We got our fans set to a nice low speed. You can see them just barely turning there, but they will ramp up once the power starts to get going there, okay? So this is all inside a closed case, 2 480 radiators, 4 D5 pumps, and we're gonna go ahead and get started. So first things first, we're gonna start with a really efficient profile. But first, let's do stock, okay? We'll probably compare our frame rate before and after just to see what it's looking like. This is a completely stock RTX 5090. We're gonna be taking a look at our clock speeds, memory temperatures, and things like that, okay? We'll do our board power to maximum and we'll reset this every time just so we can get an idea of what the power consumption is like, okay? Right now we're using about 10 watts sitting on the desktop. Any power number you see is going to be multiplied times 2 because this card is shunt modded, okay? Let's go ahead and get started. This is Furmark 1.38.1 1080p GPU stress test. This is a very power hungry test, so bear that in mind. Here we go. Alrighty, our frame rate right now is 872, 870, and our card is running 2835. The GPU temperature is 51 degrees Celsius, memory is 48. We are pulling 816 watts of power, okay? This card can pull as much power as it needs. The temperature is going to be fairly high for 800 watts, which is still pretty reasonable. 2835, very fast how it is, but it's a lot of voltage it's going to be sent to the card. 1045, 1.045 millivolts, still a lot, which is what it's sending. And we really don't need that much voltage. We can send a lot more clock speed, even with a lot less voltage than this. So that makes sense why it's going to be over 800 watts of power for the entire test here, okay? Now 400 watts, but over 800 watts of power here, okay? Take a look at our clock speed. It doesn't budge at all. It's going to be holding that 2835 the whole way. Memory is stock. And this is also a great stability test too, just in case if you want to set up a good profile and then go gaming on. I really don't recommend running 4K or even 1440p. The 1080p is more than enough. You're not going to see games use more power than this, okay? Let's move on to the next profile. This one is 2835, 800 watts of juice. We're going to close the test, okay? We're going to go ahead and reset. All right, we're going to be going after a really, really moderate undervolt, and we're going to leave everything here exactly how it is. And I'm going to need to hold down my shift key, so bear with me one moment here. I just need to grab more than one area. I'm going to start at the 850 millivolt, and I'm going to go up to the 900 millivolt range, and we're just going to max out our slider, okay? Take a look there. We're going to go ahead and hit apply, and then we're going to flatten out the rest of our curve. So we're going to hold shift here, go there. I just messed that up completely. Let me fix that. 850 to 900, all the way up, and then we're gonna go after where it goes flat. We're gonna bring that down. We're going to go ahead and apply. This is our curve. So you can see here, this is 2917 at 900 millivolt. Okay, let's go ahead and get started with this. We're gonna reset. We're gonna run our GPU burner here, and here we go, okay? We're losing a little clock speed, but not much, 2827. 620 watts. We dropped off 200 watts of power from this undervolt, literally 200 watts. You can see the temperatures are already drastically lower. And of course, you can see that our GPU voltage is 0.895 millivolt running Furmark. This is a very demanding load here. And This is a great profile, okay? 2827 is a great clock speed, completely stock, okay? More than enough juice to get you going for any game. This profile performs very well in 3D Mark Steel Nomad. It's still gonna score like 16,000. Let's go ahead and move on to a few more, and we'll start ramping up that clock speed. We'll find a good fine line in between. But 620 watts, 0.895, that just goes to show you how much power Furmark actually uses. This is Furmark GPU burner, more or less, and it is the real deal. Our fans are barely kind of turning there. I've got them set up to where they're based on CPU temperature. So our CPU is at 52. Our CPU is just not warm enough for the radiator fans to start ramping up, okay? Alrighty, 600 watts. Our 16-pin voltage is nice. It's at 12.1. Don't believe it's falling below that. I got it set to minimum, 12.1. We're using 54% TDP. And this is a nice undervolt profile right here. Lots of performance, especially considering it's gonna be using barely any power in games. This is a very unrealistic test. In a game, it's probably gonna be using about 350 to 500 watts, depending on the title. I'm gonna say 500 watts is if it's a very power hungry 4K game and you're not using DLSS, okay? Most of the time, you're probably gonna be about 350 to 400 watt range. It's gonna be very, very efficient here, okay? Alrighty, we're gonna stop the test, we're gonna reset, and we're gonna check out another profile. Alrighty, we're gonna go ahead and reset this one here, and I'm gonna go after some of my pre-saved ones. Let's take a look at this next one here. All right, let me see which one this one is. This is a good one, okay. This is 925 millivolt at 2932. Actually, this is the wrong one. Let me find the correct one. Is that it? Nope. I think this is it. Here we go. 925 millivolt, which is going to be running at 2962. Okay, so we're overclocked. We're only running at 925 millivolts, and we have our memory at plus 3000. So we're going to go ahead and reset again, and we're going to run our GPU stress test at 1080p, and let's take a look. So we're running 2880 megahertz, and we are pulling 680 watts of power, but the memory is overclocked plus 3000. The card is only using 0.9200 millivolt, which is excellent for almost 2.9 gigahertz. Okay, it's a very fast profile. We can see we're doing 889 frames per second, 891. Excellent performance here. You can just see that power consumption. This is using less power than the card stock. The memory is overclocked, the core is overclocked, and it's faster, okay? It's using less voltage than either of those previous profiles. Okay, let's go even further here. We're gonna go after a little bit more of an aggressive profile. Let me find it here, I believe. Let me see, I think it's this one. Here we go. That's it. All right. Let's bring up our memory clock. It should have been up. Okay, we're gonna reset the test. We're gonna show you what we're running. We're gonna be using 1020 millivolt at 3217 megahertz. Our memory is at plus 3000 with only 1020 millivolt, okay? That's a plus 375 offset. We're gonna go ahead and reset again, and we're gonna begin the test. Here we go. Alrighty, the card is running 3180 megahertz. It's at about 52 Celsius. We are using 836 watts of power, which is gonna be the same as stock, but it's only doing 1.02 millivolts, which is great. This is a 3.2 gigahertz profile at almost 1,000 millivolt, which is really, really good. This is where you're gonna kind of find that efficiency versus excellent performance, right? This is gonna strike that really good balance of high performance while also maintaining really good power consumption as well. While the power consumption is not very good in this test, because it is 840 watts of power, in games, you're never gonna see that. I only recommend running this to make sure your profiles are stable, okay? And as you can see, we're holding 3180, 2125 on the memory, 52 on the core at 840 watts of power. We don't have any kind of performance cap reasons, which is excellent, and the voltage is nice and low, okay? Alrighty, let's go ahead and move on to the next test. That is nice, look at that. Nice undervolting GPU. It's nice to see 3.2 gigahertz or sub 3.2 at just 1020 millivolt, especially with this kind of power consumption. Okay, we're gonna go ahead and close the test. And let's try and go after one that's a little more aggressive. Let's see if we can eke out a little more on this here. Let's go ahead and reset. We'll bring up our power, voltage, memory, and we'll go after a 10. We're gonna probably go after a 1050 millivolt here. So I'll start at 850 and we'll go up to 1050. Honestly, we really don't even need that much. Do 375 again. Okay, let's go ahead and run the test. So essentially, this profile here is going to be 3285 at 1050 millivolt, and we'll go ahead and begin the test. We are going to reset GPU Z, and we're gonna go ahead and start. Alrighty, this is gonna be 3225, 884 watts of power, and we are sending a 1045 millivolt, okay? It's a pretty heavy overclock here, but you can see how with this kind of power, we're approaching 900 watts. As it's getting closer to 450, we are temperature limited, because if you're running at 54 Celsius, your clocks could be much higher if you were running at 30 Celsius, even though this is an extremely unrealistic load, okay? 900 watts of power, all right? Our 16 pin power has dropped down to 12 volt minimum, which is good because it hasn't dropped below 12, and that is a heck of a load, this GPU. All right, let's try to press the clocks a little more. We're gonna go ahead and stop this test since it is 900 watts of juice, and we will go ahead and see if we can get a little more out of it. All right, bring up our MSI Afterburner. Max out these sliders again, max out the memory again. We're gonna go after a similar profile here, 850 millivolt at the minimum. We'll go ahead and go up to 1075, and we'll do 375 on the core just to see what happens, okay? We are very temperature limited at this point. We're gonna go ahead and reset GPU Z sensor, and we're gonna run this test again. This is 3335 at 1075 millivolt, which is more or less the max voltage of this card. All right, we are definitely temperature limited here because we're only doing 3232, and we can see here that the card is 54.8 Celsius. We are pulling 905 watts of power, and we are extremely temperature limited. I mean, it's running 55 degrees Celsius, and you can get more clock out of it with less voltage, which doesn't really make sense here, right? So it's reducing its own clocks and running slower than it would before because the voltage is excessive, right? It's not saying that it is limited by voltage. It's essentially saying that the card is idle and we need to use less voltage at this point, okay? So at this point here, this is 910 watts of power approaching, and a lot of unnecessary voltage that's needed to run 32. So we're gonna stop this test. All right, let's take a look at this and see if we can squeeze a little more out of the card. I think we're gonna go with 1020 millivolt, maybe add a little more than 1020. And we are going to start at our 850 point, and we're gonna go up to not 1025, but the next step up, which is 1035. And we're gonna do 385. We're gonna reset our GPU-Z, minimize our afterburner, and we're gonna run this test again. I'm gonna see what this is looking like. We're gonna try to get a little more, 3195 at 1035 millivolt. 1030 millivolt is very good, 3.2 gigahertz profile, 860 watts of power, and that is looking very good to me. Okay, so we're gonna keep going a little more. Try and find a good balance. Just know that this test is extremely heavy, very power hungry test here. I trust my cable and my graphics card, so I'm not concerned about this one bit. I've ran this test before, and it's been excellent. Haven't had any issues with it. The memory is only running 58, and for 860 watts, that is really, really good. Okay, so 3.2 gigahertz at 1.03 volts is pretty good. Go ahead and stop the test there. Let's see if we can get a little more out of it. A lot of power with a 5090. And as you can see, a lot of this is really not even needed. We're gonna go for the 1025. Might wanna go 1025 again. What's this? 1040. We'll go 1040 with 390. And we'll see what that's looking like. 1040 millivolt with a 390. And we will reset, and we're gonna go ahead and run again. See what kind of clocks we're getting. We are running 32, 17, 53 Celsius at 1035 millivolt, which is a good undervolt for a card like this. It seems like the silicon is really good on these. And of course, in games, you can push much higher clocks than this. It's just that this is literally GPU burner, and I'm running this for your benefit, okay? So this is 866 watts. We're running 3217 and essentially using 1035 millivolt. And this is where you come temperature limited, right? This is the temperature limits here. And this is why, of course, really good cooling or really good block to board contact is always important, okay? And another thing that I want to mention on a final note is you're never going to know what your silicon is capable of until you shunt mod your 5090. Otherwise, it's going to be a mystery forever because you're going to be constricted by the restraints of power limitation. Even when we run 900 millivolt at a mere 2800, you are going to be hitting power limits inside of this test, okay? So it's always important to remember that. Let's, whoops, I'm messing up here. 850 to 900. Let's see what that was again. Yeah, so, you know, we're running an undervolt, which is extremely efficient. 2827 at 895 millivolt, and it's still using 618 watts of power. So this test is heavy. That goes to show you right there how heavy this test is. Because in a game, this thing's gonna use less power than a 4090, you know, same power, less power than a 4090. It's very efficient. Very efficient setup. But you can see a lot of times what we're gaining here, and it's not necessarily even required. I think the biggest gain out of a 5090 is shunt modding it. That's one of the biggest advantages. And if we run our 4K test, yes, it gets even more insane. I've seen this test pull 1130 or 1140 watts of power before, and that is just crazy to see a test like that pull that much power. Matter of fact, let's try it with, so okay, that's 1080p. Let's try the 4K one. Let's reset. The 1080p was doing 627 watts of power there. So we're gonna do the 4K test. Okay, we're running the 4K test. We are pulling almost 800 watts of power. We're literally at 0.895 millivolt. Our card is running at 2850. Okay, memory is stock. Look at that, 800 watts with only 0.895 millivolts. That is crazy. That is absolutely wild there. That is some heavy power for this thing. It's nice and quiet with this profile though. You can barely hear any fans going. Barely hear anything going. The fans are barely turning. It's a pretty good profile. So I think it's all about what you're after. Of course, you can squeeze good performance out of these. You're gonna get most of the performance on a 5090 Founders Edition by shunt modding it and putting the card on water cooling. That's where most of your performance is gonna come from. And that's really it, right? I think that's the biggest benefit there. I guess when you run that in a full screen, it runs like a benchmark. So that's our benchmark. Okay, and that's pretty much it. We hit 800 watts, 700 and almost 800. We hit almost 800 watts of power there, and we didn't have any kind of performance cap reasons. The clocks held steady at 2850, 2857. GPU temperatures were 52, memory temperatures 56, 58 right there. Definitely a beast as far as it's amazing that pulls that much power. Okay, anyways, I hope you guys enjoyed this. This has just been a undervolting intro into the 5090 and the different profiles you can run on this. This test is unrealistic completely. It uses about 50 to 60% more power than an average video game. If I play Dying Light the Beast, I'm typically doing about 500 to 600 watts, whereas this here, and when I say 500 to 600, that's running like 3.3 gigahertz at max voltage, whereas this in 4K is gonna be like 1100 watts. So this is literally almost pulling, it's like an insane amount of power. So it's good for testing stability of undervolt. Just make sure your cooling is good. If you run it with a regular 5090, you're probably gonna throttle like crazy. Your clocks are gonna fall to the floor if you're not shunt modded. And this is just for information. This is just an informative video, okay? I'll see you in the next one. And I do wanna mention this as well. I haven't seen any kind of signs of degradation on my card. It pulls lots of power every single day, and it gets abused. I'll see you in the next one.